So converting from a mixed radical to an entire radical, so that would be B. Okay, we have to power up to put it to go from outside to inside, and to go from entire radical to mixed radical, we need to root to get inside outside. Okay, so in the first one here, A, we need to cube root. We need to make this into a mixed radical. So what we want to do is we want to find perfect cubes inside the cube root to be able to take them outside. And we need cube root factors. So 27 is a cube root, and 54 factors into 2 times 27. That 27 can now come out on the outside. And so that becomes the cube root of 27 is 3 on the outside, and on the inside, we're left with the cube root of 2. So there's my mixed radical. For this next one here, for B, it's got to go the other way around. So outside has to go in. So I'm going to have my fourth root. That 2 to the power x has to be powered up to go in. Okay, so we root going inside out, we power to go outside in, and we need to apply that power. Because if we look at this, we've put it into a fourth root, and we have to balance it off with a power 4. Otherwise, we don't have the original 2 to the 2 times x that we started with. We would have changed it, which in math we can't just change things. It has to stay the same. So we have the 3x squared still, and now I can combine the terms on the inside. So I end up with 16, 2 to the power 4 is 16, x to the power 4 times 3x squared, numbers with numbers, exponents with exponents. So this becomes 48, x to the power of 6. And now I've went from a mixed radical into a whole radical or entire radical. For this one here, it says, which pattern can be used to predict 3 to the power negative 4? Well, to figure out 3 to the power negative 4, we really should start with times and unmultiply or divide to get more and more negative. So if we take a look at B, we have 3 to the power 3 is 9. First of all, this is incorrect. 3 to the power 3 really is not 9, it's 27. So this is a typical mistake in that they're multiplying base with power. That is not true. Okay, they've done that with all of these. They just multiplied base with power. Okay, they did apply the negative to make it a divide, but then again they started doing multiplying base and power to get the 6. And we never multiplied bases and powers together. Okay, so because of that fact, we can just first of all just eliminate B because this is just not true. The same thing can be done here in D, where we just multiply base and power. In this case, they didn't even use a negative to show this divide, so they've made even more mistakes in D, so we're going to eliminate that. So here we have, in C, we have 3 to the power 3, 27, that's okay, that's okay, that's okay. 3 to the power 0 is okay. Once we get to negative powers, they're just making the negative using the power correctly, but the negative is not becoming divide, it's just becoming a negative number. These are wrong, it can't be C. Okay. So then by default it's A, but we should check A. 3 to the power 3 is 27, check. 3 to the power 2 is 9, check. This all works. Now when we get to the negative powers, we are applying divide. And we're dividing by 3 once, dividing by 3 twice, dividing by 3 3 times. And so the next one will be 3 to the power negative 4. We divided by 4 times. So it's going to be 1 over 3 times 3 times 3 times 3. Okay, so we've used the 3 as a divider 4 times, so it shows up 4 times in the denominator.